Hey students, this is Eric Magidson, and this is the part one of two-part series for the Chapter 1 Introduction to Systems Analysis and Design lecture. So let's just jump in and get started. We don't need to look at the objectives. We're going to cover those in both parts of this lecture series. So starting with an introduction, clearly you all are in information technology. You're living it each day. You understand that companies are using the information that they're obtaining via the web, via marketing, via databases, via all of this technology to increase productivity, deliver better products and services. We see, just a decade ago, what products and services were available, what jobs were available. We're training you for jobs that literally do not exist today, but may exist 6 months from now. A great example is social media. Yes, social media has exploded, clearly. And information technology is affecting our lives in more ways than it ever has, and it continues to do so. I mean, just look at the advent of the smartphone and the technology now and the capability and the functionality that is built into a smartphone. I'm not sure why they call it a smartphone anymore. People don't tend to make calls on it. We tend to text. We put our emotions in emoticons as if they're going to be understood. So in this class, we're going to learn about systems analysis and design, but also about what it takes to be a good systems analyst. And those are key things that we'll talk about. So what is information technology? It is a combination of hardware and software products and services that companies use to manage, access, communicate, share information, produce products and services. So there's companies that utilize it. Without the internet, they wouldn't be in business. All of these outsourcing companies, IT outsourcing companies, for example, 21st century changes in the world, changes in technology, changes in client demand, meaning our customer demand. Look at Facebook when it first got started and what was available, what the functionality was, and look at it today, where today textbook manufacturers are linking their textbooks in Facebook so that you can view your textbooks in Facebook. For me, that would be a little bit unproductive. So what is systems analysis and design? Well, it is a very detailed step-by-step process for developing, high-quality information systems. The key here is there's no one way. There's many ways, as we'll discover throughout this class. There are many step-by-step processes. Some work for certain projects, some work better for others, and of course the one that you're experienced at using or may have had success with in the past is the one that you may choose again, but it doesn't necessarily mean it's right for the project. So what does a systems analyst do? Well, they manage. That's what they do. They manage. They need to be able to communicate effectively, document effectively. And when I mean communicate across technical acumen, meaning they need to be able to communicate with a programmer who needs to understand how to program the application, all the way down to the end user who is trying to explain what features and functionalities they need to be productive inside an application that we build. So we plan, we develop, and the big one is maintain. We maintain. The majority of our time is spent maintaining or modifying or improving existing IT systems with ideas that are generated as people use our solutions. So they manage IT projects, tasks, the resources. What's the big resource? Human resource. They manage humans successfully. They do schedules for these folks. We're going to get into all of this in detail. This is just an overview. And we definitely look at cost. We have to look at the fact of, is this system cost effective? Is it going to produce revenue? Is it going to save money? Is it going to pay for itself? Are we going to get a return on our investment? And we'll look at the tangible and intangible costs that go into total cost of ownership of a system. So they conduct meetings, yes, deliver presentations to management, down to end users, trying to get end users involved in the process. Write memos, reports, documentation. Cannot kick on that enough. Document, document, document. We'll talk more about that. Huge part of the planning phase. If we document what we need in the planning phase, we're most likely going to get that when it's programmed, when it's implemented, when it's tested, when data is converted, and we're ready to go live with a new information system. So, system set of related components that produce specific results. So, what are those related components? Well, we have hardware. Now, hardware has changed because hardware may no longer be at our location. Hardware may be in the cloud. It may be in a data center. We'll look at some of this. Software, data, processes, and then, of course, people. And I like to reverse this. I think people is the most important thing that we need to manage, that we need to take care of. It's that human asset. They're the ones that make these things possible. So throughout this term, I plan on sharing my professional experience with you as it pertains to both successes and failures in doing large-scale IT projects. So these are the 5 components, okay? What do these components mean to you? Define these terms. What does it mean? Hardware, software, data, processes. Mission-critical systems, vital to the company. So an example here on campus would be COCC's Banner system. Banner is linked into the website, it's linked into grading, it's linked into financial aid. We get a bunch of data there on student success, student failure, all of this data. So if Banner was to go down today and be down for a week, this campus probably could not function as it would with the system in place. So hardware, the physical layer, we talk about Moore's law. So let's just jump over here. You can Google search these if you want. Moore's law is the observation that over the history of computing hardware, the number of transistors in a dense integrated circuit has doubled approximately every 2 years. Well, what does this mean? Just simply look at the first computer you may have operated on and then reach into your pocket and look at your smartphone. If we look at just the transformation of the Samsung Galaxy 1 to the Samsung Galaxy 7, look at how much smaller the transistors, how many processors, how much memory we're now putting into a phone. So software, system software, operating systems, application software, couple types. Horizontal, which means across industries. So an example of a horizontal software would be the Microsoft Office suite. It can be used by many different companies to do the same thing. Vertical software, this is where we get more industry specific. For example, we're going to talk about ERP, Enterprise Resource Planning Systems. ERP systems are front door to back door systems, a single unified system, hopefully, that we can manage our whole company and operations on. If we're a manufacturing plant, we might find a vertical system that meets our industry, for example, aviation manufacturing. And then legacy systems. So legacy systems are old systems. The Banner system runs on an AS400, which is an old mainframe. It's a legacy system that we're still operating on. So data, tables store data. Data can be in Excel. Data can be in an Access database. Data can be in an open source database that's terabytes in size. That's petabytes in size. I'd encourage you to go out and see how much data, how much video content is uploaded to YouTube each day. Processes describe the tasks, the business functions. So something to keep in mind when we develop an IT system is to look at the physical processes. Look at what human beings are doing today and how we can incorporate that into an IT system to benefit the company. And of course, people, many types of people. Normally we focus on what's called the end user, the person that's putting the data in or needs the data out of the system, the person that's interacting with our IT solutions. The stakeholders are the people that are financing and funding these IT projects. So today, some of these IT projects might be multi-millions of dollars and years in the making before they become productive. So that's a lot of money that companies are putting in, hoping that you can deliver an IT system. Now, one thing I would encourage you to do is go out and do a little Googling and figure out what percentage of IT projects fail today. I'm going to have you blog on that. So you'll need to know that information. 3 major trends. So rapidly increasing globalization. Yeah, globalization. We can now purchase, we can interact with companies all over the world. We can do it immediately, utilizing the internet, utilizing voice over IP, enter into their systems. They can enter into ours. We can share data that benefits companies. Integration, seamless information access. Yeah, it's called the World Wide Web. As long as someone's putting the information out there, it's available to us. Rapid growth of cloud-based computing and services. Yeah, a great example of that is less than a decade ago, if I was consulting a new company, we would build them locally, a local area network. We would have computers. We would have their email locally. We would have the Microsoft Office suite. Whereas today, we might focus on the cloud. We might still need a server, but we might build it out at Microsoft's Azure data center so that it's available via the cloud, so that it's available everywhere, not just inside our network. And who knows what we might store on that. It can be a web-based application. It could be our business. It could be, software as a service, software we've designed that our customers are consuming. All trends are internet-centric, driven by immense power of the web. Yeah, it's the internet that's changed all this. So as we look at how business is transformed in the 21st century, e-commerce. When I think e-commerce, I think Amazon. Let's look at Amazon's revenue for 2015. $107 billion of revenue was generated by Amazon. Now keep in mind, when Amazon first got started, for over a decade, they did not make a profit. Their company showed a loss. And the reason for that was they were having to take all of that revenue, all of that profit, and reinvest it back into capital expenses in the company to develop technology for shipping and receiving and storing all this data and making their website available not only to you, but to other customers such as other businesses that wanted to conduct business through the Amazon portal. So then we have business to consumer. We know what that is, business to business. We have consumer to consumer. When we talk consumer to consumer, who got that started for us? This company right here, eBay. You can sell things on eBay. Everyone can sell things on eBay. Companies can sell things to companies, business to business, consumer to consumer. You can sell that junk in your garage. So, it's funny. What's next in IT? Who knows? I mean, who really knows where we take information technology from here? I think all we need to do is look back and say, wow, that'll never happen. And then we're proven wrong. A great example of that for me personally is virtualization. When I sat where you sat in a classroom, or in this case, a virtual classroom, and someone had said to me, well, I'm going to be able to take a server or a computer. I'm going to be able to put multiple operating systems on the computer and run them at the same time. Run one as the base operating system and then virtualize other operating systems. I would have said you're crazy. But today my laptop runs 8 different operating systems in virtual environments, whereas its base operating system, its foundation, is Windows 10. So, internet-dependent firms, primary business depends on internet rather than traditional business channel. There's a lot of businesses in town that are doing this. G5, for example, outsourcing. So when we talk about outsourcing, here's an example of an outsourced company, an India-based company that does debt collection software, online training portals, recruitment software solutions, dynamic web forms, online apparel stores using Microsoft.NET, e-commerce storefront solutions. This is a software development company in India. This company, HCL, is an outsourcing company that manages IT infrastructure. There are a couple companies here in town that use HCL as their level 1 and some level 2 technical support. So their own employees are having to call India or put in a service ticket, and India will handle those. It's not till it gets to the level 3 that it's handled locally by IT staff. But if you notice, HCL has expanded, so they're doing mainframe and AS400. They're doing security. They're doing service integration and management, network services, cloud services, data center services, all from India. What makes their business possible? The internet. So back in the day, the idea of brick and mortar firms, so these were physical stores, these were the Walmarts, the Safeways, whereas now these companies are expanding into the web. Their business is open 24/7 on the web. So you can go out to walmart.com, you can do your shopping there, you can pick it up in store if you'd like, you can have it delivered, you name it. So, Lowe's, Costco, Target. When we think about Target, we might think about the fact that, they recently got hacked, and the cost that they incurred through that process was not just financial, but also the trust of their customers who had to change credit cards, who had to change debit cards because their information was potentially stolen. So, discount coupon businesses, eBay, Groupon, the internet has just completely changed how we think and do business today. Business profiles. So a business profile is the overview of a company's mission, functions, organization, products, services. It details what the company does, who they are. This is where we answer the who, what, where, when, and how. So keep that in mind because you're going to be asked to do a business profile. Business processes, so specific set of transactions, events, results. This is what a business does, okay? And we can model that graphically to understand what a business does. We're going to do a lot of modeling in this class because it gives us a visual example of who the company is, how they do business, where they do it, what is efficient, how things work together. And by having this documentation, when we talk about planning an IT system, it's about document, document, document. 80% of our time should be spent documenting, researching, redoing process. Then we go into programming the system, testing, do data conversion, and we're ready to go. So business information systems, the old way, administrative staff used office systems, operational people used operational systems. Now all employees use productivity systems, enterprise resource systems. So their independent functions are now built into a single unified system. So we're all working with the same data. Whereas in the old way, we could have data spewed over all these different systems that may be redundant. So new set of systems. So enterprise computing systems, ERP is what we're talking about. Transaction processing systems. So this might be point of sale systems. For example, McDonald's does a lot of transaction processing. Safeway, those kind of businesses. They're all about many transactions. Just go look at how many transactions Amazon does in a day, for example. Business support systems, knowledge management systems, user productivity systems. So what is enterprise computing? Supports the company-wide operations. So, Walmart's inventory system, Boeing's production control system. Boeing's production control system links into other systems within their organization, creating an enterprise resource system. So do a little research on ERP. It'll make sense. Transaction processing systems, process data generated by day-to-day business operations, customer order processing, accounts receivable, things where there are a large number of transactions. So think about this from a banking system and the number of checks and the number of debit cards and the number of ATM transactions that are processed in a day. So business support is job-related information support to users at all levels, can work hand in hand with the transaction processing system. So this can be like RFID, this can be barcode systems. These are augmented systems that help us conduct business in an efficient way. Knowledge management systems, we don't see a lot of this, but this is the idea of when we have executive management and they've made decisions for the company, what were the results of those decisions? We need to store that data so that management that follows doesn't say, hey, let's try this. Oh, well, that's already been tried, but this new manager didn't know that. So knowledge systems is where we start creating large databases of processes that we've tried, what the results are, how we've worked our business, how we may have designed new products and services, those kind of things. So user productivity, technology that improves productivity, groupware. Microsoft Office Suite, for example. The Office 365 is another great example, where we have integrated calendaring and tasks and email and assigning emails and assigning tasks and calendar. It all plays together to create a productive environment in which to conduct business. So system integration, most large companies require systems that combine all of these things together, essentially an ERP system. McDonald's, for example, yes, they have a point of sale system. When they sell a hamburger, they know they need to replace it in inventory. They know down to the minute how many hamburgers they're going to sell on Monday. They have trending. They know what their uptime is, what their downtime is, what their process time is. It's all in these systems, all generating a huge amount of data that we can then create information from by simply asking the right question. So that's it for part one. I'll start part two with what information do users need, and we'll go from there. Have a great day.